Hi. Ever wondered what bees have to do to get honey? Well, let's just have a quick chat. Well, bees are classified into a hierarchy, and we have a tier of three. So we will first have the queen, then under the queen we'll have the drone, and under the drone we'll have the worker bee. But that is not necessarily in level of importance. First, you have the queen, which is solely responsible for the livelihood of the hive. You have the worker bee, which sources the food, keeps the hive clean. The worker bee is also responsible for making sure that all the larvae and the structure of the hive is in order. And then you have the drone bee. Now, the drone bee's life is a bit interesting. The drone bee is solely made of one chromosome, which is gotten from its mother, the queen. The bee also has to carry on the gene of the mother, and that means the drone has to go outside of the hive and carry on with the gene of the mother, which is the queen, and with that it mates with other queen drones. Other queens of other hives. Unfortunately, when a drone bee mates, it dies because its genitals get stuck in the queen. So it doesn't really have a long, expectancy of life. That's pretty much the work of a bee. But now, how do they make honey? Let's call some honey to explain that. Honey!
I'm home.
That was so bad.
The worker bee uses its proboscis to suck out the nectar from the flowering plants, and in that process the nectar gets mixed with saliva that's released from the bee's glands, and it gets stored within its honey sac. Within this process, the honey is being produced within the bees. The worker bee arrives at the hive, it will regurgitate the honey with the rest of the bees, so that the honey will be made thicker.
So because the bee production process is a slow, natural one, the manufacturing process is small, done by a beekeeper who uses protective gear and smoke. He collects honeycombs made out of wooden slates. This honey is extracted through a machine using a centrifugal force, and then it's sent out to distribution factories. There you might see that the honey is heated for 24 hours, removing impurities. Usually it rises to the top where it can be scraped off. Other processes may include flash heating the honey to change its color and appearance. No preservatives are added to honey, as you will find the low percentage of water allows honey to be a natural preservative on its own.
Okay, so the volumetric flow rate is what we are going to measure today, and the volumetric flow rate is the volume of fluid that passes from, in this example, from one container to another per unit time. And then we're also going to discuss the viscosity. We're going to discuss the viscosity of the fluid, how it varies with the temperature that varies of the fluid. So let's start the experiment. So we're going to take our honey, and we are going to pour about 100 milliliters of honey into our measuring cup over there. Okay, let's just pour. Okay, that's about 100 milliliters of honey in our measuring cup. This is at room temperature, which at this moment is 22 degrees Celsius. So now we're going to pour the 100 milliliters of honey from the pouring cup into the receiving cup. We'll start in 5, 4, 3, 2, 1. We have a timer that is holding up the time for us, and stop. So the 100 mils of honey flowed from the one container to the other within about 11.4 seconds. at the temperature of 22 degrees Celsius. So what we're doing at the moment is we are heating the honey up to about 63 degrees Celsius, and then from there we're going to do the same experiment and we can compare results. Okay, so the honey is at 62 degrees Celsius and we're going to pour in 5, 4, 3, 2, go. Okay, stop. And the honey now ran at 62 degrees Celsius for 7.9 seconds. So from the we're going to do the calculations pertaining to the experiment that we just did, yeah? So we normally calculate, we're going to calculate flow rate. So flow rate is usually equal to velocity times area. But in this case, because we had the liters and we measured in time, so we're going to do the liters per second instead. So our liters was 100 milliliters of honey. If you convert that to liters, it's 0.1 liters. So we had 0.1 liters of honey. So now we're going to say the flow rate is equal to, at 22 degrees, the flow rate is equal to the amount of honey or the volume of honey we had, which was 0.1. Divide that by 11.4 seconds. So when you do that calculation, you should roughly get like 0.00877 liters per second. And then when we repeated that experiment at 62 degrees, we took the same flow rate equals to the amount or the volume of the fluid we had, which was 0.1 liters over 7.9 seconds, yeah? So when you calculate that, you should get roughly around 0.0126 liters per second, which indicates that the flow rate increased, that the flow rate was faster the second time around when the honey was more warmer or when it was at a higher temperature. Also, what I can say, at 22 degrees, yeah, your density is 1,418.5 kilograms per cubic meter. That is at 22 degrees of the honey. And then the viscosity at that point is 10.68 pascals per second. That is the viscosity of the honey at 22 degrees. And then at 62 degrees, we have a density of 1,345 kilograms per cubic meter. That is the density of the honey at 62 degrees. And then the viscosity of the honey at 62 degrees is 1.067 pascals per second, which clearly indicates that when the temperature increases from the honey, that the viscosity and the density of it will decrease. So that is all for us from today. We hope you had a good time.
Well, I found out that bees don't actually go and buy their honey, they make it. So that was quite cool. Great stuff. Also that the viscosity of honey changes with temperature, but that's basically any fluid, but honey specifically, because of the high sugar content in honey, you wouldn't think that, but yeah, it happens.
Yeah. Honey also naturally crystallizes. So at like a normal temperature, it will just naturally start crystallizing. So if you want to liquefy it, then you normally just add heat to it or whatever. But also the viscosity thing that she mentioned.
Yeah. Yes. I just want to add into what she said as well. What I've learned is that yes, viscosity is very interesting when it comes to honey, because if honey wasn't heated or above room temperature and it was colder, then it wouldn't be able to transport the honey from the one side of the workshop to the bottle itself, because it wouldn't flow, because viscosity will be too high. So as I learned, and it was a good experience. My first time, I'm not a YouTube blogger, but I learned from the best.
And then one of the things we noticed was a natural process of a production, where it's not man-made manufacturing, but there are still manufacturing processes existing in the natural world.
You ready for video?